Hi, welcome to this learning session on file permissions. Um, we'll be going through file permissions on Linux distributions and how to, understand them, what are file permissions and understanding them. How do you view Linux file permissions? How do you read file permissions? Octa, what are Octa values? What do Linux file permissions actually do? How do directory permission work, and how do you modify Linux file permissions? Well, I will make this session as fast as possible and to make you understand how it will go. Please do like and subscribe and share too, please. So we'll be dropping more videos on how to make programming easy. So now, on file permissions. On Linux system, each file and directory is assigned access rights for the owner of the file, the members of a group of regulated users, and everybody else. Rights can be assigned to read a file, to write a file, and to execute a file. That is, run the file as a program. Okay, now, how do we view Linux file permissions? Well, this is easy. It only requires using this command ls-l. By using ls-l, you see all of this. They are actually at the left side of this screen. You will see some rw, drx, something. So these are actually the file permissions. So here, um, this is how we view our Linux file permissions. So now, how do you read file permissions? Well, to read file permissions, it's easy. For example, at my left screen here, when you use ls-l, ls-l allows you to see the file permission. This it allows you to see the amount of content you have in a file, but for every file, there's only one. For directories, it lists the amount of stuff you have in the directory. For example, for this directory lesson, you have 3 stuffs in them. The next one is the root. The root, the next one, the next one is the user. That is the owner's name. And for now, I'm a super user, so I'm named root. The next one is group. The next one is the amount of bytes of data you have in a file or a directory. The next one is the last day it was modified, and the next one is the name of the file or the directory. So this is how you read a file. So how do you read a file permission? So this actually holds file permissions. Let's come to the right screen. So now in the diagram below, we see how the first portion of the listing is interpreted. It consists of a character indicating the file type, followed by 3 sets of 3 characters that convey the reading, writing, and execution permission for the owner, group, and everybody else. Like we've explained, like we said there before, um, um, rights can be assigned to read a file, to write a file, and to what? To execute a file. So now, um, for what we have here, you see at the right side there, you see RWX, RWX, RWX. This dash at the left side, this dash actually indicates the file type. It indicates the file type. So the file type, this dash indicates the file type. For this dash now, it means this is actually a file. My 5 means C is actually a file. For the D type, for the D type, it means this is actually a directory. For the L type, it means this is actually a symbolic link. You understand? So now for the next one, the next three characters, which is the RWX here, indicates the file owner permission. It shows that the file owner has the read, write, and execute permission. The next one, which is the next three, which is the RWX here, indicates the group owner. If you are not a file owner, it's either you become a group owner or you become other users. So it means you actually a group owner will actually have the read, write, and execute permission. And for the last three, it means it's for the it, other users. If you're not the file owner, if you're not the group owner, then you become what? The other users. So now, how do we read the file permissions? I believe this should explain how we read the file permissions. Like at the left screen here now, for this file means C, 5 means C, it shows that the owner has what? Read and write permission. It shows that the group has read permission only, and it shows that others have read permission only. For this directory, it shows that the user has read, write, and execution permission. The group has read and execution permission, and other users have read and execution permissions. So now, that's how we identify file permissions for file or directories or symbolic links. For a symbolic link, naturally, they all a symbolic link permissions are all full. Like for the user, group, and other users have read, write, and execution permissions. So now, um, we are still on how do you read file permissions. So now, um, here we come to what Chmod is. Well, this Chmod is a command. When you use man Chmod, so Chmod naturally change file mode bit. Well, we will come back to this. So now, the Chmod command is used to change the permissions of a file or directory. To use it, we specify the desired permission settings and the file or files that we wish to modify. There are two ways to modify the permissions. In this lesson, we will focus on one of these called the octa notation method, which can also be called the numeric method. So, it is easy to think of the permission settings as a series of bits, which is how the computer thinks about them. You know, computers only sees bits 1010. So here's how it works. For the RWX, for the owner, the computer sees it as 111. For the RWX, the group 111. For the RWX, other users 111. But this is actually in bits how the computer sees it. And anyone that is omitted here is given 0. And so on. So now this is what we'll be using mostly now, binary. So 111 in binary is 7, 1110, 110 in binary is 6, 101 in binary is 5, while 100 in binary is 4. So, and you should know, and it's good practice to know that for the read permission, the read permission is 4, the write permission is 2, the execution permission is 1. And why is this so? When this is so, because of this. These are in bits. When you convert the read permission only, it gives you 4. In a situation where you have just dash ww, you'll be having 2. That is 010, and this is it. When you have r dash dash, it means you're having 400, where r is just 4. The situation when you have dash w dash, it means you're having 020. The situation when you're having dash dash x, means you're having 001. So this is the numeric method, the octal notation method, and how to modify file permissions. So now, if we represent each of these three sets of permissions, owner, group, and order, as a single digit, we have a pretty convenient way of expressing the possible permission settings. For example, if we wanted to set some file to have read and write permission for the owner, but wanted to keep the file private from others, we would just use this command. What does this command do? When you use Chmod is actually the command we use to change. Well, this actually, it's when we come to this, how do you modify Linux file permissions? But now I'm trying to explain what are octal values. These are octal values. So these are octal values we use. So now, what do Linux file permissions actually do? Well, like I've explained before, Linux file permissions, for example, for if you were to be a user, if you're to be a user, you can give yourself um, the read, write, and execution permission. Like, yeah, I'm the root, I'm the user, and the group is having root too, the name root. So now the user, um, for a user, you have certain permissions. You have the permission for your file to read, write, and execute, depending on how you are given, depending on how you modify the permission. So now, for example, for this file junk.c, for the user, we have the user to be able to read and write, the group to be able to read, and the others should be able to read. Well, basically and initially, for every file you create, for any file you create, it doesn't have execution permissions either for the user, group, or others. Well, we use we use um we use file permissions to actually give sense more to files. You can have a file to be private to others and be opened for you. You might think to stop others from having execution permission to a file, whereas you'll be having the permission to execute the file. You might prevent others from reading the file, whereas you just have the permission to read. You might prevent others from writing into a file, whereas you will be able to write. These are the advantages of using file permissions and what they actually do. They give you what? They give you right access into a file or a directory. So now we've done what octa numbers are, what octa values are. So um how do directory permission works? Well, directory permission works exactly as file permissions. For a file, for example, this file hello.c. No, sorry, this file hello. When I run this file hello, well, it's not actually when I run this file hello, it gives me nothing. Well, this is not actually um a language. I actually changed this file to an executable file myself before. So now, for example, for every green file, for every green files you find here, they are actually executable files. So now, let's say I want to take the execution permission off this file. Let's say I want to take the execution permission of this file for um for the group. As you can see, the owner has read, write, and execution permission. The group has read and execution permission, while others have what? Just execution permission. Well, this is the last thing we'll be treating. How do we modify Linux file permissions? So, but now, what do Linux file permissions actually do, and how do direct permission works? Well, basically, you give permissions to files on either to read, write, and execute, and same things goes for directories too. For a directory, whereas you've taken the execution permission off, you should know you won't be able to use ls into it. For a permission for a directory, whereas you've removed the write permission, you won't be able to cd into that directory. And only for the directories, the read, write, and execute permissions work for each other. If you try to tweak around removing an execution permission for a directory and leaving the write permission, sometimes it might not work well. So you should note on how change the file permission of a directory. It doesn't work too well a file like a file permission. So now let's go into modifying the file permission. So now modifying the file permission, you can actually come to minuscommand.org to read more about directory permissions on what they do. Although um I can the for directory permissions, R allows the content of the directory to be listed if the X attribute is also set. W allows files within the directory to be created, deleted, or renamed if the X attribute is also set, while the X allows a directory to be entered, just like I've explained. So now that's for the directory permissions. So now how do we modify Linux file permissions? So now we can actually change permissions for files and directories, even for symbolic links. So but how do we do this? Well, so now um I've told you about the octal values, 7, like these ones, the octal values for R, which is 4, W, which is 2, and X, which is 1. Now you will see how we use these octal values in modifying file permissions. Keep note. For example, let's say we have this file junk.c. Notice the owner has no execution permission. The group has only read permission, and others have only read permissions. Let's say we want to set junk.c file to have we want to set junk.c file owner to have execution permission, and we want the group to have write permission, and we want the others to be as it is. So remember, we use the Chmod command to actually modify a file permissions. The Chmod chmod command is used to modify file permissions. You can always learn more about Chmod, and you should know. For this lesson, I will be treating only the octa notation method of file of modifying file permissions. There are actually two ways. We have the symbolic method and we have the octa notation method, which can be called the numeric method too. So the octa notation method is we using these numbers 4, 2, 1 to actually change file permissions. On the next video, we will treat on how to use the symbolic method. So now for the octa notation method, um, where we use number 421. So now um, we want to change. Okay, first of all, for this file chunk.c, let's remove the read permissions for the group and the and others and other users. So you can actually do this by using Chmod, where we have the junk to have RW, and we want to give you X, that is the execution. So we know R is 4, W is 2, and X is 1. 4 plus 2 plus 1 is 7. And we want to take these permissions off group and other users. So we give it 0, 0. Then we put in the name of the file. So by doing this, for junk file, it's done. We've removed the permissions for the group and other users. So for now, group and other users, we have no permission at all for the file. They won't be able to read, write, and execute. While for the user, for the owner itself, the owner himself will be able to read, write, and execute the file. When you give a file an execution access, the file becomes green. The color will change depending on the kind of distribution you are using. So now this is actually when we want to set a file or a directory to certain permissions. But now let's say you want to add permissions to junk file. Let's add permissions to the group. So now I want to make the group owners to be able to actually read junk file, this junk.c. So I can actually make them read junk.c. So I will say Chmod plus 0. That is for the um, user, for the owner, I'm giving them 0. It means I'm not adding anything to the user. For the group, I want to add execution. No, I want to add the read permission for the group. And we know the read permission is what? Is 4. The write permission is what? Is 2. And the X permission is what? Is 1. The R is read, the W is write, the X is executable, execution. So now for the group we want to add read, which is 4. And for other users we are giving them nothing, 0. So now when you say this and you put junk.c, enter. Now let's check. So now for junk file, we've given junk file group the read permission. Remember, even though you don't find these hyphens demarcating, you should know the first 3 is for the user, that is the owner. The second 3 is for the group, and the third 3 is for other users. So now the group has been given read access. So now let's say we want to add write access to junk.c file. We say chmod for the owner, giving them nothing. For the group, we're giving them nothing. And for other users, we are giving them write permissions. And we know write is what? 2. Then we put junk.c. So now when you ls, so for junk.c, we've given it write permission. So now you should know when I say I want to set permission for a file and I want to add permission to a file, I could use the set permission to do a mass file permission, a mass addition of permissions. Sorry, in a situation whereby, let's say for this file BGB, yeah, I want to erase every permission it has. So you should know I could just use chmod 000. By using chmod 000 without putting the addition sign, I could just say BGB and it's done. So BGB is having nothing. Neither the user, the owner, the group, or other users have any form of permissions for this file BGB. And as I've done that, I can actually give BGB its permissions back all at once, just by giving it for the user. We want to give it, let's say we want to give it read and write. Like I've told you, you can actually set permissions to a file using the octa notation. It works well, it's easy. I could give this BGB now all of its permissions by just putting 777 junk file. now BGB, sorry, and it gives BGB all of its file permissions. You know, for for um for the write permission it's 4. No, for the read permission is 4. For the write permission is 2, and for the X permission is 1. When you sum 4, 2, 1 together, it gives you 7. So by giving it 7 here, it means you are giving it all of the read, write, and execution permission for the user, this for the group, and this for other users. So now by entering this now, then ls-l, you should find BGB having all permissions complete. Isn't that great? Wow, it's cool because now we've given BGB all of its permissions for user, for the owner, the group, and the users. And now you can actually add, for example, you want to give main.h. Like I've said before, if you want to add a certain permission to either the owner, the group, or other users, you can use the plus sign, and you should know for this you are not adding up any of the read, write, and execute. You're just putting in their binaries. So now, first say for the main file, I want to give um the owner, the group, and others execution permissions. I want to give them all at once execution permissions. I could just say plus 1 1 1 main.h. With this now, 1 1 1 1 actually means what? Execution. So now with this, we are adding 1 to the owner, 1 to the group, and 1 to other users. So by entering, you see main.h, owner as execution permissions, group as execution permissions, others as execution permissions. Now I believe we've covered up how do you modify minus file permissions. So now you it's very interesting knowing how to modify file permissions. So with this you can actually prevent people from going into some files or modifying files when you are the super user, when you are the owner. So if you're to be in an organization whereby you want other users, maybe your customers, to have access to a file, maybe you want them to be able to read the file only, so they can only come and read the file. And in your company you have your groups, your colleagues, and you really want them to be able to read and write the file, so they can read and write. But you yourself, you might give yourself the access to read, write, and execute the file. And execution also means to run a file. So, and we do run applications and other stuff like that. So, and if you can prevent other people from running an application you've created by removing the execution command, sorry, the execution permission from the file. So, or the program. This is all about the octa value, the octa notation method to modify a file. You use the numbers 4, 2, 1, 4 for write, W as 2, and X as 1. You can actually change and modify the file permissions of any file, directory, or symbolic link on your minus distribution. So, and please, if there's any problem or issue, please comment and I will attend to you immediately. So thank you for watching. Please do like and subscribe. Okay, thanks.